Page 155 is discussing a very important topic in math. It's something that you really do need to understand. And as I was thinking about how to explain this, I'm not going to explain it the way they did. Okay, you can read through all of that. It's talking about a new letter that you haven't seen before, and I do want to at least name that. It's called the constant, which means it's not going to change, of proportionality. And if you're thinking, oh my goodness, what in the world? Don't worry, we're going to get it. I do want you to know that it is the lowercase letter k. So if you see the letter k in a problem, it is the constant of proportionality. So let's see what that's saying to us. All right? And I'm going to use an example from that page, but I'm not going to use their words. And I think I'm going to delete that. Bear with me just a second. Let me go back and get a graph. I want to use this colored graph. Actually, no, I don't. Excuse me. I want to use this one because I only need to see the first quadrant. When I need to see all the quadrants, I want to use that colored graph. So let's go back here. I'm sorry. So we have a picture on this page, but I want to draw this with you. So if you have some graph paper, go ahead and sketch this graph with me. Don't worry about K or anything. Let's just use common sense and calmly sketch this graph. So draw yourself a first quadrant only. And if you don't have the textbook, you're just following me. Let me just slowly explain what we're talking about here. The dependent variable in this case is going to be money. So we're going to put the dependent variable here, where 0 is down here, and every line is worth $2. Okay? 2, 4, 6, 8, $10. We want to go all the way to 22. So I won't torment you with saying that, but I want you to draw this with me. You're scaling by 2. So every box on this axis is worth $2. And let's put one more on there. Now that could continue on to infinity in the positive direction. Okay, the independent variable is going to be pounds of cherries. So I go to the market, I make a decision on how many pounds of cherries I want to buy. So we're going to have 1 pound all the way up to 7. So this is scaled in terms of 1. Each box is 1 pound more. And that could go on forever to positive infinity. So here's the basic graph that shows you the dependent and independent variables. Now, I want you to go to point 621. So it's going to be, I'm doing this with laser first, so over 6 and up to 21. So it's between 20 and 22. And let's drop a point right there. And let's label it. Over 6 and up 21. So 6 pounds of cherries cost $21. All right, let's go to 3 pounds of cherries. 3 pounds of cherries cost $10.50. So over 3, up to, not to 11, but back a little bit closer to that 10 line. I'm going to put it right here. Just get it close, it's okay. $10, 3 pounds $10.50. Okay, that makes sense. If 6 pounds are $21, then half of 21 is $10.50. And then let's go ahead and start at the origin and make a line. Use a straight edge so it's straight. I'm trying. Let me try one more time. Again, my graph is not perfectly straight, so that's about as good as I can get it to look. Okay. And this could continue to infinity. You could keep buying more pounds and the price would keep going up. Nothing unusual there. All right. The first thing that we need to do is find the slope. So how would you find the slope of this line? It's pretty steep. You could do it by counting probably, but let's just be sure and use the formula. So here's x1, y1, x2, and y2. So if in doubt at all, use the formula. So slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And here we go. 21 minus 1050 over 3 minus 6. Now something's wrong here. My y's are out of order. How did I know something was wrong? I was about to come up with a negative slope. Let me go ahead and do it for you. This is wrong, so don't write it down. That would be 1050 over negative 3. This slope is not negative. So my brain said, wait a minute, something's not right there. Look back at what you've done and figure it out. And this is what I've done. I've got my y's backwards. So it should be 1050 minus 21. That's going to be a negative 1050 over a negative 3. And then when I divide that on out on my calculator, don't forget your negative signs, I end up with something I wasn't expecting. That can't be right. Sorry. Oh, I subtracted. Okay, so 1050 divided by negative 3 is 3.5, positive. So that's 3.5 or $3.50 for what? 1 pound of cherries. All right. Stop the video if you need to until you get that slope. That's very important that you get the right slope. Okay, here's what you need to know. 3.5, actually, let's put it in point form. So 1 pound is $3.50 or 3.5. This has 3 names. Slope, you know that one, where you would say, let's put it in this form, m equals 3.5, rise over run, 3.5 over 1 is 3.5. So you can call it slope. You can call it the unit rate. That's going to require top and bottom. So if you're talking about a unit rate, you want to have a numerator and a denominator. Remember, it's the same thing. It's just a different outfit. So you could say this is called slope, this is called unit rate, and here's the new one, the one that we just introduced, the constant of proportionality. So if your college professor tells you to find the constant of proportionality, this actually happened to me, all she's asking you to do is find the slope. It's just a fancy word, a fancy term for the same thing we've been doing now for a while. He or she may also ask you to find or calculate lowercase k. Now, the textbook makes the k like this. When I was learning to teach elementary kids, that's how we were taught to make a k. So that is a k, believe it or not. Actually, no, they don't use that funky k, but some books do, so just be aware it's the k. All they're saying is that slope, unit rate, and the constant of proportionality are the same thing. They're just different names for the same thing. It's like a post-it note. You can call it a post-it note, a sticky note. I've heard another term I can't think of, but it's all referring to the same thing. It's just a different wording for the same value. That's what the page is explaining on 155. It's going the proper mathematical way to explain that to you. So don't get bogged down on page 155. If you understand what's on the screen right now, you're fine. And we're going to practice this a little bit more.